Hello. Hello world, it's Siraj. Welcome to this third live session that I've ever done. I'm excited to be here. I'm going to start off with a Q&A section, and this time it's going to be a little more structured. So I'm going to start off with a 5-minute Q&A section. Let me mute myself. Here we go. I just muted myself. Okay, so I just muted myself, and we're going to start. So 5-minute Q&A, and then we're just going to go to concepts, coding, and then summary, and then a last Q&A at the end. Okay, so let's go. Starting now. This is not beer pong. I know it should be. That would be cool. Maybe in another video. Thanks for liking my hair. I work hard at it. I dye it actually. This is dyed. It's dyed silver. Hi everybody. Hi Bartos. Hi Avirup. Tensorflow. We're going to be using Tensorflow in this video. Absolutely. I have tried implementing a generative adversarial network. Those are amazing, and they're going to do good things for generative models in general. Do I do any freelance work? Yeah, I mean, sometimes clients approach me to make videos for them. I'm trying to just do this full time. Like, I don't want to, like, you can't control me. You know what I'm saying? Like, I just want to do the YouTube channel full time. The self-driving car team is the only one that I'm like, okay, I'll do something for them. Hi, what is up, Dion and Mish? I'm going to show us how to build a recurrent neural network in TensorFlow next time. What are the dependencies? Go to the top of the chat screen. I talked about them there. Thanks, Mikolo. Hi from Argentina. I want to visit Argentina and learn salsa. No, sorry. Oh my God. I meant tango. That's what I meant. All right. All right, so here we go. 2 more minutes. Yes, I'm Indian American, yes. I'll never get it. You're right. I'll never get your nickname. Will you be using Q-learning? Good call, Lord. That's exactly what I'll be using. What is Pong neural network? Okay, so Pong neural network is, we're going to build Pong from scratch, the game, you know, with the 2 paddles and the ball in the middle, and we're going to train a neural network to get better at it over time. Hi, Antonio. Brazil sounds cool. Vignesh, I'm good. How are you? A good PDF tutorial on CNNs for beginners. Wait till later. I'll send you a link. I'll send you a link. The best massively online course for total beginners in machine learning, my channel. Just implement all the code in each of the videos, and if you do that, you're going to get good in no time. Start from the very beginning of my videos. Let's see. Game on, exactly. Hi, Kush. I am using Python 3. And can you do this using Java? Yes, you could do this in Java. Have I tried implementing 2D models, restricted Boltzmann machines? I've done videos on restricted Boltzmann machines. Microsoft AI or Google AI? Google AI, of course. I mean, Microsoft did hire a 1,500-person AI team recently, but like, I mean, you know, we'll see how that goes. Okay, so that was it. 5 minutes is over. So now we're just going to get started, okay? So now the next part is me explaining the concept. Okay, so what we're going to do is build a deep Q network to read in pixel data from the game of Pong. You guys know the game of Pong, right? 2 paddles and there's a ball in the middle, right? And it's just, you're just trying to get the ball to go past the paddle. That's it. And so we're going to have 1 evil AI. Okay, this is an evil AI. That's the guy we want to beat. It's just going to be really smart, and it's going to know everything right from the start. And then there's going to be us, and we're going to be super dumb at first, okay? We're going to be super dumb. But through trial and error, we're going to get better over time. So it's going to notice where the ball is going, and if it's losing, it's going to say, okay, I need to get better. So it's going to be using something called deep Q learning, okay? Deep Q learning. And guess who else did this? DeepMind. DeepMind did this. All it does is it reads in the pixel data. It doesn't know anything about the game. It reads in pixel data and the score, That's it. Those are the two inputs to the DeepQ network. It reads in pixel data and the score. And based on those two things, it'll get better over time. Reinforcement learning, trial and error, better over time, okay? So, and we call this the agent environment loop. The agent environment loop. Looking at the environment, the agent sees if there's a reward or not and gets better and better over time. Okay, so that's what we're gonna do. And Charles, I had coffee, but not enough. But anyway, well, we'll see. Okay, here we go. Okay, so that's the explanation of the concept. That's a 2-minute explanation. And now we're going to get started with the code. Okay, we've got a lot of code to go over because we are building this Pong game from scratch. We are building it from scratch. And then we're building the reinforcement learning algorithm using TensorFlow. So there's a lot of code to go over. That's about 300 lines, I want to say. Let's just get started, okay? Here we go. Never enough coffee. Exactly. So, all right, here we go. I'm going to screen share, and we're just going to get started because we have a lot of code to cover. Let's do this. All right, screen sharing time. Screen share. Holy shit. Hold on. Oh my God. Moving this. I'm gonna put this right here so I can see it. All right. Screenception, exactly. I'm gonna make this really big, this text really big. Okay, I know you guys like that big text. Boom, 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 boom. Getting bigger and bigger. Boom, boom, boom. No, this isn't Sublime Text. I'm writing this in Sublime Text. Is this big enough? How's that? Is this big enough? I'll wait for a reply and then I'll keep going. Is this big? Oh, bigger, okay. How about boom, 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 boom. Okay, here we go. All right, here we go. That's as big as we're getting. Okay, so the first thing we want to do is build Pong. We're going to build a Pong class. Okay, we're going to build Pong from scratch. All right, here we go. No text is big like my mom. Okay, here we go. So we're going to import pygame first. This is going to help us make graphical user interface games in Python. Pygame is a great library for making any kind of 2D game in Python, okay? Whether it's Pong, whether it's Snake, whether it's, you know, side scroller adventure game like even Super Mario. You could build it in Pygame. I love it. Check it out. Read the docs. All right, so this is how we're going to build Pong. The next dependency is going to be random, all right? Pygame and random. And I'm going to upload a copy. I'm going to save a copy of this video and save it to my channel. So check it out later if you have to go, okay? And so the random is going to help us define which direction our ball is going to go in, okay? All right, so let's start off by defining some of our variables. Define variables for a game, okay? The first one is going to be the frame rate, okay? So let's just say 60. That's going to be the frame rate for how fast our game is going to move. Next, we want to have the size of our window, our game window, okay? So that's going to be the window width, and which is going to be 400 pixels, and then window height, which is going to be 400 as well. So it's going to be a square window, same width, same height. All right, the next step is to define the size of our paddle, okay? So that the paddle is, you know, the stick that the ball hits, okay? So paddle width, and they're going to be the same for both us and the evil AI. They're going to be the same size. So we're just going to have to define it once. We'll say 10 pixels, and then we'll define the height as 60 because the height will be, it'll be longer than wide, right? Okay, so that's the size of our paddle. And now we want the size of our ball. Size of our ball. Okay, so the size of our ball will be, let's say ball width, and then ball height. It's going to be 10. All right, So that's the size of our ball. And now we want the speed of our paddle and ball, okay? So how fast do we want our paddle and ball to move? Yeah, the size of our ball, because our ball is actually not a circle, it's a rectangle. It's a very small rectangle. All right, yeah, please, ball jokes, go in the comments, keep them up, I love it. I love it when you have big balls. Here we go. So the speed of our paddle and our ball, so we want our paddle speed, it's going to be, let's say 2, and our ball x speed, which is the x direction of our ball, and then our ball y speed, which is going to be 2. And so x and y speed, we have 2 different speeds for our ball. Which direction, x and y, right? There's an x-y coordinate plane. And there's 2 directions in Pygame, right, in our window. We're having a ball with these ball jokes, aren't we? I love it. That was clever, top 1%. Okay, so now we want to define our color spectrum. So we're gonna have our RGB colors for our paddle and ball, So we're going to have, let me just go up. We're gonna use white, which is going to be, what is the color for white? 255, 255, and 255. That's gonna be the color of our paddle and our ball. And now we're going to define the black, which is the background for our game. 0, 0, 0. That's it, okay? Those are our colors. Now let's initialize our screen. Initialize. We're going to randomize we could randomize our speed. I mean, it doesn't really, we don't want to get that complex right now, okay? So let's just initialize our screen. So we're going to say screen is going to be, so we're going to use the pygame module to initialize our screen. And so we're going to use the set mode method of display to set the size. And we're going to use our variables that we've created, our width and our height, to define the screen, okay? That's our window width and our window height. Okay, great. Now that we've initialized our screen, let's draw our ball, okay? So now we can write our first function here called draw ball. We're going to draw our ball. It's going to be a small rectangle, okay? And so the 2 parameters are going to be the x position and the y position that we want to draw our ball in, okay? So our ball is, we're going to define our ball variable, and we're going to use the rect function of Pygame to create that rectangle, that ball rectangle, okay? And so let me make sure I didn't misspell this. And I'm going to say, let's initialize our rectangle with our screen as the parameter, and then, sorry, not our screen. We're going to use our x position, our y position that we input as parameters, where we want to start off with. And then the width, our width for, oh, Suraj for president. I would be down, actually. I would be down. That would be awesome. I would techify everything. I would just make everything run on code. It would be amazing if I was president. Okay, so future plans, future plans. Let's make this YouTube thing work first. Ball width and then ball height. You guys are so awesome. Man, I love you guys, seriously. Like, I've had my ups and downs in life. Like, I've been feeling pretty down lately, but like, just the fact that, like, you know, I've got you guys, it makes me feel better. So thank you. Okay, so here we go. Make America learning again. I know I've got to focus. I know. The comments are so amazing. Okay, anyway, so that's our ball. And now we're going to draw our ball. So pygame.draw, okay? So we're going to draw our ball using the draw function. We've already defined the rectangle, and we're going to use our screen, our color, and then our ball that we just defined to define our ball. Okay, that's it. That's how we draw our ball. Okay, now we're going to, thank you. Now we're going to draw our first paddle. And our first paddle is us. Okay, that's us, that's us, and we're going to learn over time. Okay, so our first paddle, we're going to draw paddle 1, and we're going to use the first the position as our parameter, okay? So we're going to do the same thing. We're going to create our paddle using the pygame rect method, and then we're going to use our paddle buffer as the first parameter, and then our y position, and then our width and height, okay? So that's going to be how big it's going to be and where it's going to start. And the reason I used a buffer is to show that it's not, so that it doesn't hit the edge of the screen. All right, ball, 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 ball. Okay, so that's our ball, and now we're going to draw it just like before. So pygame.draw .rect, and it's going to be white as well. Screen, white, paddle 1. All right. Okay, so that's our first paddle. All right. Now we're going to do the same thing for our next paddle, and draw paddle 2. That's going to be our evil AI. That's the guy we want to beat. He's going to be really good. We want to beat this guy. All right. He's on some shit. Okay. See, I never know if I can or cannot curse, or if I should. So I just do it anyway because, like, whatever, you know what I'm saying? I have nothing to lose. Okay, so paddle to Y position. All right, so, okay, gotta focus here. I'm gonna answer you guys, but I gotta focus. So now paddle 2 is going to be, we're gonna do the same thing. We're gonna draw it using the rect function, and then we're going to say window width minus paddle buffer, so it doesn't hit the edge of the screen. And then we're going to say minus paddle width, right? Minus paddle width, and then paddle to Y position, and then paddle, and so then the size of it, paddle width, and then paddle height. Okay, I gotta keep going here. All right, and then we're going to draw it pygame. .draw, .rect, and then the screen, and then our color, and then our paddle, okay? I should use a Linux machine. I agree. I agree. I will eventually. I will. Okay. So now here comes the hard function, okay? Okay? Here comes the hard function. We're going to update this ball, okay? This is the function where we update the position of the ball. So we're going to say update ball, and we're going to take in parameters. The parameters are going to be the position of our, both of our paddles, our ball, and the direction that the ball is going. Those are going to be our parameters. So we're going to take those, we're going to say paddle 1, Y position, paddle 2, Y position, and then ball X position. We're going to say the ball Y position. That's the position of our ball. Position. The window width is spelled wrong, right? I'm going to line 40. Let's see, where is it? Window. There you go. Thank you. Appreciate it. That's spelled wrong. Ball Y position, ball X position, and line 40 U caps R. Thank you. Thank you. Appreciate it. Appreciate it. Boom, boom. All right. So that's the position of our ball, and then we want a direction of our ball. So the ball's direction is going to be the ball X direction, and then the ball Y direction. Okay. So those are our parameters, and now we can just go ahead and get started. Line 32 instead of rect, typo fixed, 36 capital, also capital typo fixed that. Okay. So now, okay. We have got to get through with this. Okay, so we're going to update the X and Y position. Update X and Y position. So the ball. So we want to update the X and Y position of our ball. Okay, so that's how we're updating the speed of our ball and where it is. So ball X position. We're going to take the original position and we're going to add the direction that it's going in, and we're going to multiply it by the speed of the ball. Okay, and so that's going to update the position of our ball. Okay, depending on how fast it's going and where it's going. All right, so ball Y position plus ball Y direction times ball y speed. Okay? All right, there we go with that. And we're going to say the score is going to be 0. It's going to start off with no score. I mean, the score is going to be 0. And we're going to update the score. And we're going to return the score as well, depending on. All right, I'll try not to explain every step. Balls, exactly. So now we're going to check for a collision. Okay, so this is going to check for a collision. And if the ball hits the left side, then our learning agent will switch the direction. Or the ball is going to switch the direction. Okay, so there's going to be a bunch of if statements here. So we're going to say if ball x position is less than the paddle buffer plus paddle width, and the ball y position plus the ball height is greater than or equal to the paddle's position, and the ball's y position minus the ball height is less than or equal to the paddle 1 position. 1 y position plus the paddle height. All right. So this says, okay, so I'm going to write down what this means. This means we're going to check for a collision, and if the ball hits the left side, if the ball hits the left side, then we switch direction. So we're going to say ball x direction is 1. Okay, else if it doesn't, so then the ball's position is less than or equal to 0, then we're going to have a negative score. So we're going to change the direction of the ball, and then we're going to make the score equal to -1. Okay, and we're going to return, and we want to return whatever we've just calculated. So we're going to return the score. We're going to return the paddle's position for both of them. We're going to return the ball's position. We're going to both the x and y position, and we want to return the direction of the ball. We want to return, that's the x and y direction of a ball. Boom. All right. This is crazy. Okay, there's a lot of variables going on right now. Okay, and then, all right. Can't see code. I know, right? It's okay. We're not going to be able to see all the code because we have to switch between like how big the text is and like there's a trade-off between how big the text is and how visible it is. Thank you. The score is -1. Thank you. All right. Now we want to check if it hits the other side. So if ball x position is greater than or equal to the window width minus paddle width minus paddle buffer, and the ball y position plus the ball height greater than or equal to paddle 2 y position and ball y position minus ball minus ball height is greater than or equal to paddle 2 y position plus paddle height. Okay, thank effing God that we are done with those two statements, okay? Fuck. Right, okay, so we did that, and now we're gonna switch the direction of the ball. So so this basically means if it hits the other side, then we wanna switch directions again, right? So now we're accounting for both sides that it hits. So ball x direction equals -1, all right? And then else, if it doesn't hit it, so else if the ball x position is greater than or equal to the window width minus ball width then we want the positive score. So the ball x direction equals -1. And the score is 1. And now we're going to return that same shit, right, that we returned up here. The same thing. And the score is here. And now I'm going to look at the comments for a second. Boom. Hi. What am I saying? There's too much lag. All right, this salty ball X position. All right, here we go. So now, cool. So now, okay. So let me just explain what I just wrote, and let me make this smaller for a second. Hold on. We're checking for a collision here. Okay, so we're saying if the ball hits the left side, then switch directions. If the ball hits the right side, then switch directions again. So it's basically the logic is, you know, if it hits one of the sides, then we want to switch directions for the ball. All right, that's all. That's all. All right, break the line, break the line, break the line, break the line. Lots of line breaks here. Okay, there we go. All right. And I'll keep the font size, and I'll break this line, and I'll break that line, and I'll just fit it all in here. All right. Boom, 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 boom. All right. Okay, so now, oh, and there's one more thing we need to account for. What if the ball hits the top? What if the ball hits the top? We don't know what to do then, right? We have to account for that. So if the ball's Y position is left center equal to 0, then we want to make that Y position equal 0. So then we want to change the direction of it. And we want to say, else if ball Y position is left center equal to the window height minus the ball height. All right, so if it hits the bottom, then we want to change position as well. So ball Y position equals window height minus ball height. Okay, and so then we want to make the Y direction ball Y direction equals -1. And eventually we return the score. We return the score. This is two-player Pong, exactly. But one of them is an AI, an evil AI that's already really good, and one of them is an AI that we want to make better. Okay, boom. I'm going to fix the colons. Yes, thank you. Boom. Anyway, so there. Okay, that's it for that method. Thankfully, we are done with that method. Oh my God, that was so intense. Okay, so now we have two more functions to do. Okay, so let's do it. Yeah, it's AI versus AI. It's a bad AI and then a good AI. That's us. That's us. We're going to get better over time. It's already going to be good from the start. All right, so here we go. Let's update paddle 1. I'm going to update the paddle position. If we move up, so if the ball moves up, so that's going to be us. So if the action is 1, so depending on where we're moving, like which direction we're moving in, we want to update the position of our paddle, right? So we could go up or down, right? So the action is just an array of where it's going, right? So up or down. All right, so paddle 1 Y position equals, so we're going to update the position of our paddle, and we're going to subtract the speed of it, right? And we're going to add this colon. So now if it moves up, so now it's if it moves down, if action is 2 equals 1. So if we try to move down, then we want to update the position to move the paddle down, okay? Paddle on Y position plus paddle speed. Okay. Don't let it move off the screen. Okay, so if the paddle, so if it tries to go above where we want it to go, then so less than 0, then we're going to update that. Let me see where we are right now. Okay, cool. So paddle 1 y position equals 0. And then I'm going to say paddle 1 y position is greater than window height minus paddle height. Okay, so now we have taken into account every possible scenario that our paddle could move in. Okay. All right. Thanks, Acrylic. Love back from San Francisco. So we want to do the same thing for paddle 2, right? So I'm just going to copy this method or function, and we're going to do the same thing but for paddle 2, right? And the difference is we're going to say ball y position, and this is going to be paddle 2. All right, now we can define our Pong class, the game of Pong, right? We are moving really fast here. We haven't even gotten to our AI yet. So let's just define our Pong class. Def init self 64 colon at 64. Where are you talking about? No, I didn't. Okay, so now we want to define our game. Okay, so this is our game class. This is now we have our functions. We want to define our Pong game. Okay, so we're going to start off by saying random number for the initial direction of the ball. Where do we want our ball to go? We'll define our random number using the randint function. I know this is a pretty long program. I'm thinking like let's just keep going. We just need to keep going here. So random int, we're going to start from 0 to 9. So it's going to be a random number between 0 and 9. Okay, and now we're going to keep the score. In order to keep the score, we're going to define a tally variable. Self.tally equals 0. Now we want to initialize the positions of our paddle. Positions of our paddle. All right, so now we're going to say self.paddle 1 position is window height divided by 2 minus paddle height divided by 2, and self.paddle is window height. So it's going to start off in the middle, basically. That's why we're dividing by 2. We want it to start off in the middle. Window height divided by 2 minus paddle height divided by 2. All right, so now we want to define the ball direction. Ball direction definition. And we're going to say self.ball x direction is 1. Self.ball y direction is going to be 1. And then the starting point for our ball. The starting point will be the self.ball x position is going to be the window height divided by 2, and then so it's going to start off in the middle as well, right? So the ball width divided by 2. All right. Now we're going to say 2 more functions, okay? We're going to define the get present frame. All right, so these are 2 more functions and we're done. Colon 94 and 109, I'll remember that. Okay, so now we want to get the present frame. So that means the frame that we are currently at. Why are we defining this function? Because we want to feed our reinforcement learning algorithm the pixels, right? So we need, in order to get the pixels, we need to get the pixels from the game. All right. So for each frame, we need to call the event queue. All right, so pygame.event.pump. Like this is going to be like if we need to repaint our window or anything, and we're going to repaint if we need to run anything. So that's why we have pump. So now we want to make our background black. We want to make our background black, so we're going to run our fill function. Okay, so screen.fill, and we're going to say black. So that's what's going to be our background. All right. I know it might just explode when I run it, but that's okay. Draw. Now we're going to draw our paddles. So we're going to say drop. So we're going to call the functions we just made, right? We're going to draw our paddles. And we're going to use our Y position first. And then we're going to draw the next paddle, paddle 2. And we're going to say self.paddle 2 Y position. Now that we've drawn our paddles, let's draw our ball. And guess what? We made a draw ball function. Let's call it. All right, this is everything we've just done. And we're going to say it's going to be at the X position. We're going to initialize it at that X position, and we're going to use that Y position as well. Okay. Now we've drawn our ball. We've drawn our paddles. We've drawn our ball. We've drawn our screen. And now we want to take all of those pixels from the entire game, and we're going to return that. And how are we going to do that? Well, let's define a variable called, let's say we want to get pixels. So let's define our variable called image data. Okay, we're going to define a variable called image data, and image data is going to use the array 3D function of pygame to get the pixels from the screen. So we're going to say surf array dot array 3D. All right, and we're going to say pygame dot display dot get surface. Boom. So that's going to get all of our pixels. Now we want to update the window, and we're going to say pygame dot display dot flip. All right, Leonard, I'll definitely take that into account. We're going to update our window, and now we want to return the surface data. Return the screen data. All right, so we're going to return image data. Exactly. Okay, so that's going to return the screen data. And we want one more, okay? We're going to want one more function to get the next frame. So it's going to be def get next frame. And we want to use self, and we want to use action, okay? And the reason that self and action are going to be our two parameters. Action, we're going to use action because the action is what direction we want to move in, all right? And we're going to define this later when we create our reinforcement learning algorithm. So for this, we want to do the same. We're going to start off the same way. We're going to say pygame.event.pump to call the event queue. And then we're going to fill the background screen in just like we did before because it's for the next frame. Thank you. And Saurav, you're just wait. We're almost done with it. In 4 minutes we'll be done with this, and we'll get to the reinforcement stuff. That's going to be super interesting. Okay, just hold tight. So now we're going to update our paddle, and we're going to say self.paddle 1 Y position, and then we're going to update our paddle using the paddle method we just defined, and we're going to say the action. And then the action is going to be fed back to us from our reinforcement learning algorithm that we already do. All right. Action is going to be, hi Victor, thank you. The action and then the self.paddle 1 Y position. All right. And then we want to say self.paddle 1 Y position. We filled our screen. We want to draw our paddle. 1 self.paddle 1 Y position, and then we want to update the position of it. Self.paddle 2 Y position. We're going to update the position of the evil AI, right? Y2 equals update paddle 2. Boom, and then self.paddle 2 Y position, self.ball Y position. All right. So, okay. So that's going to update both of our paddles over time. And then we want to draw the ball. So draw ball, self.ball X position, self.ball Y position. Now we want to get the surface data again. And so we're going to do the same thing that we did before. We're going to get the surface data. So I can just go ahead and copy and paste that. And then update the window. So pygame.flip, just like we did before. And then return it, and that's it. Okay, so that we're going to say pygame. Oh, and we want to record our tally, right? Self.tally is going to be whatever we are plus the score that we've added. Okay, and now I know PEP8 is going to kill me later. So we want to return the score and the image data. Those are our two things. Okay, all right. These are the two inputs that we are going to feed into our reinforcement learning algorithm: the pixels on the screen and the score. Okay, so that's that class. All right, and so now we have this Pong class. Let's do our reinforcement learning algorithm in TensorFlow. Okay, we're going to do our reinforcement learning algorithm in TensorFlow. All right, so let's just start off by importing TensorFlow. Okay, and hi, Madi. Hi, Fernando. Okay, we're going to do this in TensorFlow, and we're going to import. So TensorFlow is to do machine learning. CV2 is OpenCV, and that's going to help us format our pixel data so it's good. So that it's better for reading into our TensorFlow graph. We're going to import the Pong class that we've already created. And thanks, Arav. And we're going to import NumPy as NP, which is going to help us with math. We're going to import random, which is going to we're going to initialize some random things later. And then we're going to import the collections library. And from the collections library, we're going to import DQ. Okay, DQ is going to be it's a data structure. DQ is a Q data structure, and that's where we're going to store our experience replay. Okay, we're gonna store some memory in this Q function, and I'm going to explain why we're going to use that. So let's go ahead and start off by defining our hyperparameters. See, I'm just like much more interested when we get right into the machine learning stuff, because you know what I'm saying, like that's where it's at. Okay, so these are our hyperparameters. We're going to start off with our actions variable, and our actions variable are up, down, or stay. Okay, let me see. All right, so now we want to define our learning rate. Learning rate is going to be gamma, and we're going to set it at 0.99. Now we want to define our epsilon. So I'll talk about what our epsilon is. So we're going to say initial epsilon is going to be 1.0. And then our final epsilon, where we want to be after training, is going to be 0.05. So what is this? This is when we update our gradient or training over time, we want to make sure our epsilon reaches 0.05. Okay, and we're going to apply this later. How many frames do we want to anneal our epsilon? Okay, so how many frames? So we're going to define those frames. We're going to say explore frames. That's going to be 50,000 frames, and then our observe frames are going to be, sorry, these are 50,000. This is 500,000. Okay, so now, thanks, Daniel. What kind of neural net is this? Great question. Let's just, I'm going to define that. Let me say that in a second. Let me just define two more hyperparameters. Our replay memory, which I'm going to talk about, and what kind of neural network this is. So replay memory is going to be 50,000. And then our batch size. Our batch size is going to be 100. All right? So batch, so how many times we want to train. All right? And now we want to create our TF graph. Okay, what kind of neural network is this? This is a convolutional neural network. A convolutional neural network is a type of neural network that reads in image data. And we're going to make a 5-layer convolutional neural network. Thank you for that. In TensorFlow. And we're going to feed the pixel data and the score into this convolutional neural network. And that's what's going to help us do deep reinforcement learning. Okay? And DeepMind did this. They did this for all those Atari games, and no matter what Atari game they gave it, it was able to just look at those pixels and become amazing over time. All right? Exactly, Lin Wang, exactly. So now let's create our TensorFlow graph. Let me just go down a little bit, and so we're going to say, okay, so create our graph. Create graph, and let's get started. So now we want to say create our first convolutional layer. Our first convolutional layer is going to convolutional layer and our bias vector. That's what we're going to first create. So I'm going to define that first. I'm going to say first convolutional layer using TensorFlow variables, and we're going to define the size of it, okay? And we're going to say these sizes can be changed to be whatever numbers, but I'm going to have these be these numbers because, okay. We're defining our first convolutional layer, okay? And we're using the tf.zeros function to define those layers. What tf.zeros does is it creates an array of an empty tensor full of zeros. It's an empty tensor, which is good for us because our convolutional network is going to start off empty, and we're going to fill it with data over time. And we want to define the size of it, okay? We want to define the size of it. So we're going to say b convolutional 1 tf dot, and so our bias vector will help us how much we want, so where we want our data to flow, like in what direction. And so our bias will help us in defining like what part of the network we want our data to flow in. Okay, so we're going to say tf.zeros, and we'll define it as 32 because it's 32 bits. So it's 8 by 8 with 32 bits. And so that's our first layer. So now our second layer, and wow, there's 231 people watching this. That's awesome. Wow, I'm so happy. Like, this is awesome. Let's get more interest in machine learning, guys. You guys are gonna love it when oh my God, okay. You guys get me pumped. Okay, I love it. You guys get me pumped. All right, so now for our second convolutional layer, we want to, okay, how long is this going to take? This is going to take about, I want to be done within 15 minutes. I want to be done in 15 minutes, okay? I want to have the entire thing done. Well, we'll see how long it takes. So let's define that layer. And we'll define our next convolutional layer. tf.variable, tf.zeros, and 4, 32, 64, b convolutional 2 equals tf.variable, 64. And then our third layer, just got to keep defining those layers. Bum, bum, bum. Three equals tf.variable, tf.zeros. Okay, we have a lot of explaining to do, and I'm going to explain these magic numbers in a second, all right? So let me just write this shit out, and we are going to explain this stuff. All right, all right, all right. That's how we do it. So tf.zeros, and we want this to be 64 bits as well. Okay, that's our third. Fourth, and so now our fourth. Okay, so now our fourth is going to be WC4. Okay, nope. FC4 is equal to tf.variable, and tf.variable, and we're going to say zeros, and it's going to be the size 784. And we're going to use our actions as a parameter here. I'm going to explain this in a second. And then our bias, let me just code out all of these layers, equals tf.variable, tf.zeros again, and then 784. I will upload the source code. And then last layer. Okay, last layer is going to be WC5 equals tf.variable, tf.zeros, 784, actions, the FC5, tf.variable. So, you know, it's just a very repetitive thing when you're coding your layers because it's just, you know, layer after layer, you have to define each of them. And then we want our input. Okay, so what happened here? Let's see, like, all this stuff you guys have said. Okay, so we created 5 layers, and each of them we defined a size, an input size, and we define an input size, right? Oh, thank you. Parenthesis there. Yeah, I would be in a TED conference. Yeah. So we define the size for each of these layers. Line 42 is the wrong variable. What are you talking about? Oh, it needs a, no. Oh, no, there we go. 250 plus people now. Wow, you're right. 263. Oh my God, this is crazy. Oh my God, this is crazy. Okay, here we go. So we have 5 layers to our convolutional neural network, okay? And so now we got to keep going because we are running out of time, out of time, out of time. Okay. Analogies are great here. So yeah, that's a good point. That's a good point. So now we want to create our input. Where is our data going to go? We created this 5-layer neural network, and where do we want our data to go? Well, we have to create an input, right? A placeholder where the data feeds into the network, right? Okay, so let's create an input for our pixel data. We're going to feed our pixel data into this input. So we're going to say tf.placeholder. We're going to say float and none 84, 84, 84. All right. So this is where our data is going to flow into. Okay. So now we want to do our actual activation function, which is going to be the rectified linear unit. Every time, make pixels great again. That was great. Every time we feed data into this, at each layer, we need to perform some kind of computation. We need to do something to that data. Okay, everybody keeps talking about line 42. So let me just quickly look at what is happening here. BFC4. All right, thank you. BFC4. Thank you so much. So at every layer, we are going to perform the rectified linear unit activation function. Okay, it's going to take that data and it's going to turn it into a probability. And so ReLU is in use a lot. And oh, you're right, I only have 28% battery. I need to make sure, oh my God, I am really on a timeline. Okay, so here we go. So let's compute our ReLU activation function on 2D convolutions given 4D inputs and filter tensors. All right, so we're going to compute it every time using the TensorFlow's built-in ReLU function. Okay, let's take our 2D convolutional neural network, and oh man, okay, all right. 2D convolutional neural network, and then so we're almost done. All right, we have 6 more lines of code. Okay, and then we're gonna get through this. Okay, so no, we have about 12 more lines, and then we're good. So we're gonna take our convolutional neural network, and let me just make sure where I am. Okay, so I need to calm down. Everything is good. It's all good. Meditation, mindfulness. I know my battery's going to die. I'm going to die. Everybody's going to die. But hopefully, if we can put our minds into computers and machines and merge with them and make the singularity happen, we won't die. Okay, I just said that. So now we want to input that. So we're going to perform our convolutional. Is there really more than 300 people in here? Oh my God, this is crazy. Hi everybody, welcome to Becoming Awesome with Suraj. So we're going to take strides. So our strides are like the channels that we want our data to flow through. We want to say padding is valid, so that's just a that's a variable for. Okay. I just have to code this. I literally just have to go right now. So tf.nn.relu, tf.nn. Actually, I could just literally just copy and paste this. You know what I'm saying? I just changed the layers here. I say convolutional 2, convolutional 3, and then convolutional 3. And then I need to say, I'm going to take, I would say 10-ish years. Yeah, singularity, 10-ish years. Okay, so what's happening here? We're taking all the data that's computed in each layer and we're sending it to the next layer, okay? Now we're going to take that last convolutional layer, convolutional 3, and we're going to say tf.reshape it, and we're going to take the previous convolutional layer and we're going to say -1, 3, 1, 3, 6. and then we're going to say FC4. I know I have to fix that typo. tf.nn.relu, and we're going to perform matrix multiplication on that function to make sure that that is working, and we're going to use our reshape. Okay, and now our last layer is going to take everything we got from before, and we're going to perform matrix multiplication on it. And if we do that, then we have our output tensor, right? FC5 is going to be our output tensor. That's going to be the result, and we're going to feed that back into the network. Okay, and so we want to return that. We want to return the input tensor and the output tensor. Okay, so let's just get right to our main method now. Okay, boom, boom, boom. Def main. In our main method, because we are running out of time, in our main method, we want to start out by creating a session, a TensorFlow session. In our TensorFlow session, we use tf.interactiveSession. That's the method we use to initialize a section. And then we want to define our input layer and our output layer. I can't even think right now. Our output layer. Okay, and we're gonna we just defined a method to do that, right? That create graph method, or is that what it's called? Yeah, create graph. Create graph is going to create our input and output layer for us, and we're going to feed those into our training graph method, which is going to take both of those, and it's going to run our reinforcement learning algorithm on. And then if main equals main, call main. Okay, so literally 300, oh my God. Literally, no, you guys are not just as smart as me, you guys are like smarter than me. I've got people who are subscribed to me who are just smarter than me, okay, in a lot of ways. We all shine in different ways. I'm good at being in front of a camera, you guys are good at other things. I know there's a lot of errors, and we are running out of time because I only allocated an hour for this, and this is my third time live streaming, and we have we're gonna have some errors here, and I do not have time to fix the errors here. But let me explain what I've done, okay? Let me just go over what I've done. What have I done here? I've defined Pong from scratch. I've defined a bunch of variables for defining for what the game is gonna look like. We're going to draw the ball. We're going to draw both of our paddles. We're going to update the position of our ball. And then I have 20% battery. We want to update our paddles, like where they're going. And then we're going to define a class for our Pong game. We're going to say, okay, get the present frame and then get the next frame. We're going to take that pixel data, and then we're going to feed it into our convolutional neural network, our DeepQ network, which is a convolutional neural network. It's a 5-layer convolutional neural network, and we built these with TensorFlow. Okay, we're going to input that using this placeholder variable. That's where the data flows into the network. Okay, and once we do that, we're going to apply the ReLU activation function in each layer of that network, and we're going to, by the end of it, it's going to, using our agent environment loop in our training graph method, we're going to be able to train our network to be better and better over time. Okay, so I don't have time to fix all the errors right now. So what I'm going to do is I'm just going to run what I already have, and so you guys can see what this looks like. Okay, can you guys see this? Yeah, you guys can see this. So I'm not doing anything, right? I'm not doing anything. I've got 17% battery, and the thing is, like, my MacBook sometimes dies at like 15%. Sometimes it dies at like 17. So it might just die right now. So I want to make sure I'm able to upload this code or this video to my YouTube channel, and it works. So see, there's the evil AI, and then there's the RAI, and it's going to get better and better over time, right? Right now it's really bad, but if you give it like, a couple hours, it's going to get better and better over time. Typical MacBooks, right? So that's how it's going to look. It's going to get better and better over time. And now I'm going to stop screen sharing, and I'm going to answer 2 questions, and then I'm going to upload the code. I'm going to have it well documented. I'm going to add the stuff that I wasn't able to get to, and I'm going to do other awesome stuff for you guys. So 2 questions. Let's go. 330 people watching. Hi, Daniel. Hi. We got Daniel Schiffman. We have got to do something together, okay? Max, you know, I might visit SF State. Send me an email. Why the ReLU activation function? Because it's good for deep Q learning specifically. More live, maybe next week. Maybe next week. No, Daniel, don't worry about it. Hi, Shamrock. I love you too. Well, let's be in touch. What is reinforcement learning? We're using the agent environment loop to get better and better over time. It's like trial and error. Like if you give a dog a treat and if it does something, that's reinforcement learning. You're reinforcing it using a reward function, okay? And cool, who painted my hair? I do it at a salon. What's next? We're gonna do more neural network stuff, more machine learning stuff, and we're gonna do it in a way that's more accessible to more people. I might give a TED Talk. You gotta come to me. Like I don't have time to like go out and like try to find a TED Talk. Books for machine learning I would recommend. Deep Learning Yearning by Andrew Ong. How long have you been learning ML? It's been, how long has it been now? Maybe like 3 years. Blockchain stuff, I used to do that stuff. If you want to see blockchain stuff, go to the beginning of my channel. I used to talk about that a lot. I wrote a book on that called Decentralized Applications, one of the best-selling software engineering books in the world, by the way. Can it be done with Keras? Yes, absolutely, using a Theano backend. A book for Python, learn Python the hard way. Why not use a charger? I don't have time. And for now, I've got to go get my charger. So thanks for watching. And I love you guys.